Thank you, Han, for the warm introduction and great to be with you all today. Thank you. I think this is such an important topic that we're all learning about. The health of our soils and our ecosystems is probably one of the most pressing things that we have to solve for as the human species. Looking forward over the next 5 decades, 100 years, it's so important that we are custodians of this, 6 inches of soil that covers all land and is basically responsible for all vegetation that we see. So the health of soils is so critical. And just to further to what some of the colleagues touched on today, the essence of a good, healthy soil is really organic matter. Because when you look at unhealthy soils, you see very little organic matter because if there's no organic matter in the soil, the earthworms can't function, the mycelia can't function. So really getting that organic matter content up in the soil through various techniques. No-till is probably the starting point. Applying mulch, cover cropping, various other forms of sustainable agriculture comes into it. But having a good organic matter base is really one of the essential elements in getting your soil nice and healthy. And of course, when you over apply anything, specifically synthetic fertilizers, it really does degrade the organic matter in the soil. So if you want a rich, humified, mineralized soil, you really got to look to applying as much organic matter on the top of it as possible. And I'll show one or two slides on that towards the end. But these are also some of the unseen in the soil. And Kirsten was talking about mycelia. And these effective microbes that are under the microscope are so small, but there are literally billions within a square meter of soil. And when we start to convert, especially these over-farmed conventional spaces, and they're often missing this essential element in the soil, which is the effective microbes. And the science is pointing us to the fact that we've got very similar effective microbes in our own stomachs, in our guts, which enable us to digest the food and the nutrients in the food specifically. So there's this very strong link between the soil and our gut as the human species. So when we look at soil, we can't separate ourselves. It's part of a living organism. We sometimes look at soil as like an inert substance. It's just dirt outside, but it's so alive. And when you put it under the microscope, it's fascinating to see all the various forms of microlife that exist in a tablespoon of soil. And as Kirsten was touching on, this underground network of mycelia is fascinating. And there's so many different varieties of mushrooms. And we're only just starting to understand the importance of mycelia, not only for the soil, but also our health. There are so many different types of mushrooms we can take as medicinals that are starting to supersede pharmaceuticals, quite frankly. So all of the answers exist in nature, and it's really quite a fascinating thing. This is just a small example of one of the measuring tools that we've got in conservation, organic, regen, agriculture, is to start looking at the health of the leaf. Because if your soil is healthy and your plant is pulling up all of these amazing minerals into your leaf, and you actually analyze the leaf sap, you're able to determine how healthy your soil is. So when you look at this table over here, you can see it's stacked from 1 to 20 plus. And right in the beginning, 1 and 2 is where your soil is not healthy and you are susceptible to all types of diseases, specifically aphids, which really start to appear at 6 and 8. And then sucking insects start to appear at 7 to 10. And then chewing insects start to appear at 10 to 12. And grasshoppers, for example, are also at 11 to 13. So the further you get up the bricks matrix, the less pest and diseases that you have. And that is a direct result to healthy soil. So this is a scientific way to test the leaf sap and to determine what's missing in the plant from a mineral perspective. And it's such a great tool for organic and agroecology and conservation practitioners to understand that this is a really great tool to start looking at and how we go about it. And one of our other colleagues was talking about no-till farming, and this is really strong in the conservation agriculture space. The less that we disturb our soil, the better for the microlife. It's quite simple. You expose your subsoil to the sun, you're going to bake away your microlife. So, I mean, it's a really simplified concept. This thing of continual plowing, sometimes twice a year. It's actually, when you start to really understand the science behind it, it's not a great practice globally, and we really have to shift out of that. And starting towards no-till is really the first step in conservation ag. So no-till, heavy mulching, and keeping your soil covered so you can have your earthworms, your mycelial network, and your microbes well protected beneath vegetation cover. I'm not going to go too far into this, but this is just a concept that everything is interconnected, from your trees right down to your organic matter, your mycelia, all the little chocos that exist in the soil, the worms, and it's actually an interconnected food web, which allows us to understand ecosystems in a more scientific way. So when we also see ourselves as part of this food web, our connection to nature and the soils is really quite a critical thing for us to understand as a human species. And the further that and the deeper that we understand this, the more connected to nature we become, which is where we need to go. We need to remember ourselves that we're part of nature. We're not separate from it. And I just wanted to show this quick slide over here. And when you look at all the various forms of ecological agriculture, the new one that's really on the block, you've got regen, you've got conservation ag, of course, you've got organic agriculture. But syntropic agriculture is fascinating, and we're currently on a course here with it, so I'm bringing it up because it's very relevant for me personally. But you can see the fields over there, and this is a shot in Spain, in a highly drought, very dry space, extreme temperatures, 48 degrees in summer, and very little irrigation is happening on that green block. And this is about a hectare, and there's over 4,000 plant species here on this piece of land. And you can see the fields on the left are barren and dry, and they're not making it. I mean, it's been continually plowed, right? And this is a no-till system where you plant up extreme density and you give it as much plant cover as possible. So you're actually farming photosynthesis. You're getting the plants to stack in various layers. And this is how nature does it. This is how forests actually design themselves. But I think, yeah, I mean, it's quite a simple process. Bed preparation, just stacking the plants in there. And you can see on the right-hand slide that the density of the plants is extreme. So there's just so many different forms of agriculture at our fingertips that are more sustainable, that offer us nature-based solutions where we're not looking to synthetics to fertilize our plants. Healthy soil, healthy plant, healthy people. And I think that's where I'm going to leave it for the afternoon. Thank you for the opportunity to talk to you all.